As we prepare to start our new unit on organic chemistry, we want to make sure that we review gram formula mass and empirical formulas. Organic compounds are unique compounds that typically have empirical formulas. Organic compounds are covalent compounds that contain at least carbon and hydrogen. Today we're going to review how to calculate gram formula mass, also known as the molar mass. The gram formula mass is called the molar mass because it's equal to the mass in grams of 1 mole of a compound. In order to find the gram formula mass, you should find the sum of the masses of each element in the compound. You'll use the subscripts provided in the formula to do so. So in this formula for magnesium phosphate, notice that there are 3 magnesiums. Phosphate is in parentheses, so we'll have to distribute the number outside the parentheses to each element inside. In phosphate here, we have 2 phosphorus and 8 oxygen atoms. You can find the mass of each of the elements on your reference table. Multiply the reference table mass times the number of elements to find the mass for each element. Magnesium phosphate has a gram formula mass of 263. Okay, so now I'm going to walk you through how we can calculate the gram formula mass of a compound. The first compound we are going to look at is water. Water is a covalent compound where the valence electrons are shared because both hydrogen and oxygen are nonmetals. That can be a little bit confusing sometimes because when we look at our periodic table, hydrogen falls to the left of this bold staircase. But remember, hydrogen is not a metal. In order to find the gram formula mass of a compound, you're going to have to look up the average atomic mass. Now, when we look at the key here, you can see that the average atomic mass is in the upper left-hand corner, right where we should write the mass number of an element. For the purpose of this class, it is always okay to round your atomic mass to the 10th place. So hydrogen has a mass of 1 gram per mole. So I'm going to write the mass in the upper left-hand corner, and oxygen has a mass of 16. So hydrogen has a mass of 1, and oxygen has a mass of 16. But when I look at my formula, I see there's a subscript 2 here. That's because there are actually 2 hydrogens. So I'm going to have to multiply by the subscript so I can count for each of the hydrogens. And then I'm just going to have to add up the total masses. And so our final answer is 18.0 grams per mole. Let's try a slightly trickier problem. Here we have calcium chloride, an ionic compound. This is an ionic compound because when we look at our periodic table, you can notice that calcium is a metal and chlorine is a nonmetal. Now, ionic compounds transfer their electrons, and they are attracted because they are opposite charges. So calcium has a charge of +2 because it's lost 2 electrons, and it gave 1 electron to each chlorine, making them negative. Now, when I look on my reference table, the atomic mass of calcium rounded to the 10th place is actually 40.1. And the atomic mass of calcium rounded to the 10th place is 35.5. Now, when I look here, calcium has no subscript because there's only 1 of them, but there's 2 chlorines. So I'm going to have to multiply this by 2 and then carry out my math. So my final answer is 111.1 grams per mole. Sometimes in a chemical formula, you'll have parentheses. That's because we have a polyatomic ion. So this is an ionic compound because magnesium is a metal and nitrate is a polyatomic nonmetal ion. And so what we know is nitrate has the charge of -1. So all 4 atoms covalently bonded together have a single charge of -1. So notice that the total charge of my compound is 0. So a total charge of 0 is an indication that the compound is formed to obtain stable noble gas valence electron configuration. So here, what we have to do is look up the masses of these elements. So magnesium's mass rounds to 24.3. Nitrogen's mass rounds to 14.0, and oxygen's mass rounds to 16.0. But we have to take into account the subscripts. Since there are parentheses, that means that the number outside the parentheses distributes to each of the elements inside the parentheses. So from our picture, you can see that we actually have 2 nitrogens, and we actually have 2 times 3 or 6 total oxygens. So first I'm going to carry out the multiplication. And now I'm going to add these 3 values together. So I get 148.3 grams per mole. The empirical formula is the smallest whole number ratio of atoms in a compound. So for instance, if we took this fictitious compound, B10G20, and we found the greatest common factor between 10 and 20 and divided, we would have an empirical formula of Bg2. To determine the empirical formula, all you have to do is divide the subscripts by the greatest common factor. Look at this organic compound called butane. 4 and 10, the greatest common factor is 2. So the empirical formula is C2H5. Sometimes you'll have to determine the molecular formula when you are given the empirical formula and the molecular mass. Know that the molecular formula is always a multiple of the empirical formula. For instance, compounds with the empirical formula CH4 could be CH4, or if we multiply by a factor of 2, it could be C2H8, or if we multiply by a factor of 3, we could have C3H12. In order to calculate the molecular formula from the empirical formula, first thing you'll want to do is to find the gram formula mass of the empirical formula. Divide the given molecular mass by the empirical formula mass, and then multiply all the subscripts in the empirical formula by that number. The next calculation I'm going to walk you through is calculating the molecular formula given an empirical formula and a molecular mass. There's a 3-step process to solving these problems. Let's get started. The first step is to take the empirical formula and find the empirical mass, or the mass of this formula. So here we have carbon and hydrogen. Now carbon, from our reference table, has a mass of 12.0 and hydrogen has a mass of 1.0. But we have a subscript here for the hydrogen, so we'll need to multiply by 2 for the hydrogen. Now that I have the masses of each of the individual elements, I'm going to add them together. So my empirical mass is 14 grams per mole. So step 1 is done. Find the empirical mass. Step 2 is to divide the molecular mass by the empirical mass. Dividing by the empirical mass, I get a factor of 4. That means that my molecular formula is 4 times larger than my empirical formula. So what I'm going to have to do is distribute this 4 through the empirical formula. So the third step is to just do that distribution. So instead of having just 1 carbon, I have 4 carbons. And instead of having just 2 hydrogens, I have 4 times 2, or 8 hydrogens. Now to check your work, you can always find the gram formula mass and make sure it matches the given mass. So to do that, I would take 4 times 12 and add that number with an 8. And so when I check this, this does have the same molecular formula of 56. So I did a great job. Okay, so in this question, again, the question is the same. So here we're given an empirical formula of C3H4, and we are given a gram formula mass of 120. Remember, this first step is to find the empirical mass. So here I know that carbon has a mass of 12 grams per mole. Remember, you just get the masses from your reference table. And hydrogen has a mass of 1 gram per mole. Now here I have 3 carbons, so I'm going to multiply by my subscripts. So now I can see that my empirical mass is 40 grams per mole. The second step is to divide the given molecular mass by the empirical mass that you calculate. So that's 120 divided by 40. That would equal 3. And the last step is to take this factor and multiply it through in your empirical formula. So 3 times 3 is 9, and 4 times 3 is 12. So this is my formula. Okay, the last example we're going to look at is this example. Here we have the empirical formula of a carbohydrate. Those are those energy molecules we learned about in biology, and we are given a molecular mass. First step, find the empirical mass. So here I have carbon, hydrogen, and oxygen. Carbon, we can round its mass to 12.0, hydrogen 1.0, and oxygen 16.0. Now carbon has no subscript, meaning there is just 1 carbon. There are 2 hydrogens, and there is only 1 oxygen. So if I complete my multiplication first, and then I'm going to add these up, I have a gram formula mass of 30. Next step, divide the molecular formula by the empirical mass. And the last step is to take this whole number and distribute it through your empirical formula. Make sure you don't just write it in front of the formula, but you actually distribute it. So that becomes C5H10O5. So this is a 5-carbon sugar, sometimes called pentose and sometimes called ribose. Maybe you've heard of deoxyribonucleic acid. This is the sugar that is part of that vitally important molecule. This concludes the lesson on gram formula mass and empirical formulas. Make sure that you complete your homework on Google Classroom, submit your notes, and I hope to see you soon in office hours.